Hi everyone, my name is David Montgomery.
I'm Jonathan Armstrong.
And Jonathan and I both work in the Digital and Computational Pathology division of Cerdan. Very quickly, the first part of the presentation, we're going to talk about a multidisciplinary approach that we use within the organisation. Then I'll hand over to Jonathan, who will touch on how that's been leveraged within the research team. So I think to start with, it helps to think about what pathology actually is. I think a lot of people think silent witness. They think an eerily lit laboratory in the dungeons of a hospital, which isn't thankfully true most of the time. And it's ultimately responsible for making 70% of diagnoses and across the vast majority of clinical pathways. It's the study of disease. It's vitally important, obviously. And of late, there's been a seismic shift away from glass microscopy, which is traditional pathology, looking at a glass slide under a microscope, towards digital pathology. And there's a number of key motivations for doing that. The first one is just an awfully large workload for pathologists. The next one is then, a real shortage in pathologists actually across the globe. So in the US in particular, there's a lot of pathologists, board-certified pathologists that have actually retired of late, and that's continuing. There's a recognition globally that AI can be very, very valuable in this space, not just from a computer vision perspective, but also looking at optimizing workflows and quality assurance and the likes. There's also a couple of other fundamental problems that need to be addressed around healthcare interoperability and also some very dated software and hardware actually in the labs. So there's a lot of terminal interfaces there with very, very poor user experiences. I thought I'd throw this one up actually because when I started to think about what makes a dysfunctional team, for some reason, botashi, the very, well, I'm not going to say it's a really popular Japanese sport, but it's a Japanese sport that it's sort of a mixture of capture the flag, wrestling, MMA, and sumo combined. For those of you in an SME who thinks they want to try this in some evening for extracurricular activities, you need 75 people on both teams, so it's quite a challenge. So hopefully, your communication in your multidisciplinary teams don't work just quite like this. It's a bit more, hopefully, harmonious. In terms of multidisciplinary teams, then Cerdan, we're a BelTech, so it's equally as important to think of multidisciplinary in the sense of medicine as well as traditional technology. A couple of papers up here, one's from Frontiers in Oncology. It talks a lot about the value of a multidisciplinary team for improved patient care. So it talks about oncologists coming together with radiologists, radiographers, pathologists, primary care, nursing staff, and physiotherapists to bring about the best outcomes for patients. And then on the true technology side, I really like this paper from IBM Research actually, which focuses on the benefits of using a multidisciplinary team approach across 7 quite detailed programs of work over several years. And these sorts of approaches are quite widely accepted now, right? And they're much more than just shift left. So it's more than bringing a QA analyst into into project initiation meetings, or more than bringing a security analyst into, for example, agile ceremonies. It's about bringing all the stakeholders together to solve much more holistic problems. And if I reflect in my own career, I look back maybe 10 years ago and think about, we were building a sort of low latency risk management platform in capital markets. We were really proud of the architecture. Functionally it was sound. It addressed all the non-functional requirements that we needed, but it failed due to regulatory changes. And there's a real breakdown in communication between what we referred to as the business and then the technology as well. So we definitely could have done things better. Technology could have been more probably forceful in terms of explaining how simply it could have been changed and refactored, but it failed, simply for that reason. So taking some of those into account, Cerdan have sort of developed this approach over the last couple of years, really. And it's pillared upon and centralized on a combination of design thinking and user-centered design. So it takes the best of both worlds, I'll say. So there's ideation, there's brainstorming, but then there's also a large focus on user testing and making sure that we take into account the issues that we have with our current systems and make improvements. But around all that then, there are a whole plethora of different forums that we use to help build the best products we can. One is community of practice, so all our products effectively have a dedicated community of practice. There's a little screenshot in the top right-hand corner. It's all been remote recently, of course, but that brings together, pathology partners, potential buyers in the hospital, so maybe administrators, IT administrators, clinical scientists. It's a really good feedback loop. We get lots of information. We can make lots of improvements to the products that we build, and there's a really fast approach to failure as well, which is good. Building a partner network is really important, particularly in AI, of course, as well. So some of the names across on the right-hand side there are people that we've engaged with. Some we've got quite an esteemed history of working with, actually, and some are more recent. They vary from large private labs in Australia to public labs in the UK, for example. And also there's the KTP program that we've been heavily utilising over the last few years. We have a Pathology Horizons conference every year as well, which has been really, really valuable to us because it brings together the thought leaders in digital pathology, and that helps us keep abreast of the current state of the art and make sure that's catered for within our products. As well as that then, we have a growing internal SME capability with an awful lot of clinical knowledge, which is excellent. We bolster everything with a lot of frequent engagement with customers, not just within that community of practice. And something that's come to the fore very recently is, particularly for widespread adoption of AI in the NHS, is around how you get patients involved in the process too. So, for example, at Pathology Horizons this year, we had Margaret Grace, an MBE, talk about how she feels about companies like ourselves using her data and how we should use it sensibly. Now, I want to touch on a very quick case study before I pass over to Jonathan. But before I do that, I sort of need to explain a little bit about a standard pathology workflow. So it starts with potentially a biopsy or some surgery of a patient, and samples then come down to the lab and they're received and accessioned. So we sort of create barcodes, we create glass slides, cassettes ready for the rest of the process. It's then grossed by a clinical scientist or histotech, so they're cutting the sample down into more manageable pieces that can then be processed. It's processed, dehydrated, so that it can then be embedded within paraffin wax. It's then cut using a microtome into very, very thin strips, and then using a water bath, it's applied onto a glass slide. And that's the end of the traditional pathology workflow. But as we move into digital pathology now, then those glass slides are digitized using some sophisticated scanning technology. And those are then transformed into ultra-high resolution gigapixel images that are typically between probably 2 and 6 gigs per image. And I suppose using the approach I've just described, we've been building this product called Ultraview. So Ultraview is effectively a digital slide tray and a whole slide image viewer, but it's also the framework for our AI model execution as well. It's secure and reliable. It adheres to a lot of the recent healthcare interoperability standards like FHIR and a number of annotation standards for AI too. It supports remote collaboration, and it's vendor agnostic, so it supports the vast majority of the leading scanning vendors in the space, people like Leica, Hamamatsu, and Aperio. And then just to touch on some of the benefits that we've realized to date using this approach. And it's still a work in progress. We'll continue to see these as we go through, and as we release the product more and more. But some of the early things we've seen is, there's definitely an increased confidence that we're actually building the right product for our customers. We've got a lot of positive feedback, but also through those community of practice sessions, we have been able to feel fast. There's been plenty of times we've gone into those sessions and they've said, we don't agree with that, you know what I mean? And a bit of consensus, and we pivot and we move in a different direction. But also then internally, our working patterns have changed. There's much better collaboration and engagement between internal teams. Working relationships have improved, and there's been a vast improvement in clinical knowledge actually across the various teams as well. So the culture has dramatically improved as well, which is excellent. And now I'm just going to pass over to Jonathan, who's going to touch on then how we use that approach specifically within the research team at Cerdan.
Thank you very much, David. So as David has said, sort of giving you a view of how we use the multidisciplinary approach just in a general technology aspect, but we feel it's very much key to developing good AI in the industry is using this multidisciplinary approach. And so you might be asking, well, why is AI relevant in medicine? And David's already hinted at some of the staffing issues in the US, but probably one of the most sobering stats I read recently was by a consensus by the Royal College of Pathologists. And they estimate that the NHS, only 3% of the labs have enough staff to meet clinical demand. And when you think back to that number, that 95% of clinical pathways, 95% of times people go into a hospital, it goes through a pathology lab, and then only 3% of pathology labs have enough staff. That's a massive discrepancy. There's a big, big issue there. It costs $27 million a year in outsourcing, in other different things. Sometimes the pathology slides we've been hearing about, are sent away to Australia to be diagnosed overnight, but that makes a big difference. And so we feel AI is crucial to this process. And I just wanted to talk you through a program that's been going on in the UK for a while. It goes here in Ireland as well. And it's around the screening programs that are ongoing. It's the aim to try and catch cancer early. One of the outcomes of the screening programs are colon polyps. So if you go for a bowel cancer screening program or for just a routine colonoscopy, you'll come across colon polyps. Those colon polyps make a difference because they're a little skin tag that's in somebody's colon. Those need to be taken out, harvested. But one of the things I found interesting was I was in a pathology lab recently, and there was a lady at the desk behind me, and she just shook up this wee pot and she said, "Dear me, I have to look at these 20 polyps here." And that was from one person. So these already understaffed labs then are looking at an awful lot of normal situations where maybe only 1, 2, 3 of those polyps have actually something meaningful, i.e. cancer or something like that, for the person's diagnostic pathway. And so those polyps then need to be taken out, need to be sliced up, as we've already heard, and here on the image you can see what it looks like under a microscope. And so alongside Dr. Maurice Loughrey, who's a head GI pathologist in the Royal Victoria Hospital here in Belfast, we spent quite a bit of time collecting a data set and an awful lot of time annotating that data set. First of all, it's a strange problem to have, but because it was medical information and tissue, we had to go through an awful lot of ethical approval to get these images, first of all. Then he taught me quite a bit of how to actually diagnose or look at these slides and see where the tumorous areas are in these slides. And then now we have finally 500 fully annotated patches or images, whole slide images that you've already been hearing are maybe 2 more gigabytes in size. These generate thousands then of training patches that are available for our AI algorithms. And while we were building that data set, then we did quite a bit of work, not just with the Royal, but then we moved and did quite a bit of work with ESIT here in Queen's, Dr. Paul Miller as well, developing and testing out algorithms for medical applications. So testing the various different algorithms, testing the amount of patches, the size of the patches, where that all falls in accuracy curves, and where the most important areas to focus on from a data point of view are for us then to be able to translate that into the whole slide polyp images. Once we got the actual polyp images and started using them, we reached the conclusion that a UNet architecture was probably the best approach, because the UNet allows you to, on a pixel by pixel basis, make a classification, classify what's there in the image for every pixel, which is it's a lot more meaningful in digital pathology, where they're massive images and basically every pixel is nearly a cell. And so we reached relatively good initial accuracies with those. But one of the things that sort of was a blow to me nearly, and it came through this multidisciplinary approach, was when we sat down with the clinicians and showed them the outcomes of what we thought were really exciting algorithms, and how the algorithm actually was finding so much interesting information in a single slide. They started asking, I sensed, sort of annoying questions of, what else can this do? We can see that with our own eyes. How's this going to speed up my diagnosis? And it was a moment where we had to sit back and say, they're right. It was really a penny drop moment for us in saying, yes, the AI is very interesting and relevant and good at extracting information from those images, but we need to do more with it. We need to actually use that information in a meaningful way. And so we moved from not just showing them, as I call, pretty pictures, but moving into the more auto-reporting approach. And you can just imagine a pathologist sitting down in front of a whole slide image like this, already digitized, but they see that tumorous area. They already know what's there, so it's far more meaningful when you think back to the 20 polyps case, that you sit down with them and say, look, there are 20 polyps. These are the most serious. Each polyp is X in size, extent. There's the tumor size, there's the tumor area, there are the amount of cells in each image. All of that is pertinent information. It was already going on in the background of the algorithm, but it was just that step into making that information meaningful for the clinician on their day-to-day basis that made the difference. So the AI, it's really important to remember, AI is brilliant, but it's only as good as the tool, because it's a tool that you're using against the data. And so a standard polyp report would be something like you see here. Here are two different from our two different hospitals we work with. You know, each polyp has to be classified, has to be given a size, has to be said where it's from. All of that information can come out just from the AI algorithms and from our current medical systems, but we hadn't made that leap. And that information is very relevant because say 3, 4, 5 of those polyps are pre-malignant. Out of the 20, that person is a high-risk person, and that means that that person has to come back every year for a checkup rather than every 5 years. And so if you're saying the clinician comes in the morning, those 20 polyps have already been looked at by a system, an AI algorithm. There is a report sitting there supporting that information and allowing them to pick off the most serious cases early in the morning. They can report on those out. They can sign off on those reports very quickly. That's what makes a difference to the workflow. Rather than saying, you know, here's some help in looking at an image you've been looking at for the last 20 years. That's not that relevant. They want the additional leap. And so some of the key takeaways I would leave with you today then, just following up on what David has already said about communication, about a multidisciplinary approach. Communication, it builds trust. If you bring your clinician and your whole team along on that journey, whether it be AI or whether it be developing your product, that's how you're going to build trust. We've heard already a couple of times this morning about explainability. We're doing quite a bit of that in the research aspect, but from a clinician's point of view, if you hand them a report, explainability to them is taking that, seeing and looking at the viewer that we've already heard about, and seeing where those points were diagnosed. So where did the maximum length of the tumor come from? Or where was the area calculated? All of that is good and explainability from their perspective as well. Collaboration, well, it's really mandatory. You know, you need to understand your customer. You need to understand what their pain points are. And that was a big leap that came to us as a research team. Coming out with interesting research, they had additional questions that really helped our approach. And especially when you're working in the medical field, it's important to remember that the final customer really is you. It's not just understanding what the hospital needs are, but the final customer is the patient. If 95% of the clinical pathways go through a pathology lab, if they're understaffed, it makes a massive difference to how quickly those diagnoses come out the door. And some of the key learnings that the multidisciplinary approach has then brought to our AI team, and from a research aspect, is that AI is a brilliant tool. It provides an awful lot of general information right across either slides or whatever other application you're using it for. But all that general information can then be used for specific tasks. That information can be fed into a specific polyp report. Maybe it's a bowel cancer screening program database to build up their database. All of that is relevant. And I'd probably just leave you with this point that be very careful of the line, let's use AI. That nearly got us into issues when we decided to use AI, walked up to the clinician. They didn't feel that the AI was that interesting. They wanted to see how it made a difference to their day-to-day. And so AI should be seen clearly as a tool to be used in your arsenal, from your tool bag for your research teams to be using AI. It could be extremely advanced models that have been developed, or it could be off-the-shelf models, but with high-quality data. That's the tool. There are other uses that can be done as well, right across the spectrum. Even, basic statistics can sometimes make a massive difference to the general workflow. So thank you very much.